Hello everyone, today we're going to continue lesson 6.5 day 2 and we're going to be dividing polynomials using another method other than the long division. We learned long division with polynomials yesterday, and so we're going to actually start using synthetic division, and I'm going to tell you that you are going to like synthetic division a lot better than the long division, I think. So here's another way to divide polynomial. It's called synthetic division. And I don't think that anyone has been exposed to this method yet if you're taking this class for the first time. So using synthetic division when the divisor is x minus a. Now, what it means is, you know how in the previous lessons we have the divisor. Let me just go back to the last problem we did in the previous lesson. When the divisor was like an x squared term, like these ones, that's not a linear term. Okay, that's actually quadratic. So it only works. So there's a restriction, guys. It only works for problems when the divisor is linear, like this, only x, only the degree is x, okay? So that's the restriction off the top for synthetic division. So we gotta be careful with what we use, how we use the synthetic division. And so that basically is what we do for the synthetic division. Before we use synthetic division, let's start with synthetic substitution. So we're going to actually just substitute the number in, and I think that most of you still remember how to substitute, right? So we're going to use direct substitution. So we're going to basically look for p of -2. Basically, wherever x is, I'm going to substitute -2, correct? So that's 4 times -2 to the third plus 3 times -2 squared plus 2 times -2 plus 1. And if you use a calculator, you can go ahead and follow along to get the answer. That's -32 plus 12 minus 4 plus 1, and that should give you a -23, right? So if you use direct substitution, you have evaluated p of -2 is equal to -23. Everyone should know this because everyone at one point should have learned how to substitute, correct? Now I'm going to show you the powerful method of synthetic division. So using synthetic division, so basically this problem is already done. We have just found p of -2 using synthetic substitution. So basically we just use direct substitution. But I'm going to show you how we use synthetic division to get the same answer. So this is how synthetic division works. We only work with the coefficient. So we're going to line up the coefficient and make sure that it's in standard form and nothing is missing. Remember, if there's a missing term, we have to put a 0, right? So the coefficients are 4, 3, 2, and 1. And underneath the last term, we're going to put a little bracket right here. That will tell us what the answer is. So the divisor is -2, which means the solution, the number, the factor is -2. The answer that we're going to use to divide is -2. Now, there is a difference between the solution, which is -2, and the factor. The factor form is x plus 2, but the solution is x equals -2. So hopefully that makes a difference. Right now, we're working with -2, right? So in long division, we would use x plus 2, but in synthetic division, we would only use -2. But basically, those two mean the same thing. So we start by putting -2 outside the bracket. The first step is to bring down the first coefficient, and then anything that is outside, we're going to multiply. So 4 times -2, and we're going to put the answer right there, which is -8, correct? Next thing, we're going to combine those two answers. 3 and -8, that gives us -5 as a balance. And then we're going to multiply again. -5 times -2 gives me a +10. And I'm going to combine those two, so repeating the steps, that's 12. And then I'm going to multiply again. That gives me -24. And I'm going to combine, and voila, I have the answer. What do you guys notice? Does that look familiar? That -23 is the same exact answer that we would get when we use direct substitution. So this is the new method of how synthetic division works, okay? I'm going to have you guys practice one more substitution, and then we're going to get into how to actually use synthetic division. So we're going to again substitute by finding p of 2, -3 times 2 to the third, plus 4 times 2 squared. Make sure you guys try the problem before you look at the answer, okay? And working it out, we have negative 24 plus 16 plus 4 minus 5, which gives us negative 9. So if I use synthetic division, I can just easily verify this using the coefficients of negative 3, 4, 2, and negative 5, and the substitution of the solution of 2. We're going to bring down negative 3 and multiply. That's negative 6, combine negative 2, multiply negative 4, negative 2, and negative 4, and that's how we get negative 9, which is the same answer as substitution. But I'm going to go a lot slower in the next problem when we actually do the synthetic division. So I just wanted to quickly verify that for you to show how they are connected. So the substitution and the synthetic division are actually connected. So we're actually going to try a problem using the synthetic division method. And notice that they want you to write the result in the same format that we did with the long division. So here we go again. So we're going to set up the synthetic division with the L bracket, and we're going to again make sure that it's in the dividend is in standard form, and we're only going to bring down the coefficients. So that's 3, negative 17, 15, and negative 25. Now the number that I'm going to go outside, remember this is the long division form, but I need to put the factor, the answer form, which is solution. So x is equal to 5, right? Remember when you solve x minus 5 equal to 0, and you add 5, you get x equal to 5. So 5 goes outside, even though the factor is x minus 5, right? And then don't forget the little bracket in the back. So step 1, bring down that 3 in the front. I'm going to multiply 3 times 5, right? So 3 times 5 is 15, and you're going to place it right there underneath. You're going to combine the 2, so that will be negative 2, and then you repeat. Multiply again, that's negative 2 times 5, which is negative 10. You're going to combine these 2 again, and you get 5. You're going to multiply again, 5 times 5 is 25, and notice that it gives you the 0 as the remainder. So we're going to write the answer, p of x is equal to the factor form. Now remember, when we put it in the answer, we got to put it back in the factor form. So it's x minus 5 times the quotient, which is 3. And the way that you write the quotient is you're going to reduce the factor, the degree of the original polynomial by 1. So that will be x squared, and then x, and then 5. So we actually have 3x squared minus 2x plus 5, and then plus 0 as the quotient, the remainder. So there is no remainders, but we just put plus 0. I'm going to try one more right here. This time, the factor is x minus 1/2, which means the 0 is actually x equal to 1/2. So we're going to put that outside. And the coefficients, notice that this is all over the place. So we're going to have the coefficient of x to the 4th is 4. We're missing an x cubed, so we're going to have 0, right, for the next number. And then negative 3 and 7 and 2. Those are the coefficients. And we put a little bracket there. First step, bring down the 4, multiply. Half 4 is 2. Combine the 2 and 0, that's 2. Half of 2 is 1, combining we have negative 2. Half of negative 2 is negative 1, and we have 6. Half of 6 is 3, and that gives us a remainder of 5. And we're going to put the answer, p of x, in the standard form. That is the coefficient, which is going to be x minus 1/2, the quotient, the divisor. And then the answer here is going to be reduced, so that's x cubed plus 2x squared minus 2x plus 6. So that's going to be 4x cubed plus 2x squared minus 2x plus 6. And the remainder is 5. So that's a plus 5 at the end. And this is how you divide using synthetic division. So hopefully you now know how to do that. And let's go ahead and have you try a couple of problems before you look at the solution. Hopefully you've tried it. And let's rewrite the answer again, the dividend in standard form using only coefficients. So that's 2, 5, negative 1, and 7. And then we have x minus 2 is the factor, so the solution is 2. So the number that's going to go outside is 2. Bring down the first number and multiply. We got 4. And then 9 times 2 is 8. And 8 minus 1 is 7. 7 times 2 is 14. 14 plus 7 is 21. Actually, I made a mistake. 9 times 2 is 18. And that's going to be 34. So it should be 41. And so again, we're going to reduce everything by 1. So it's 2x squared plus 9x plus 17. And we're going to write the answer as p of x is equal to divisor, which is x minus 2, times the answer, which is the quotient 2x squared plus 9x plus 17, and then plus the remainder of 41. And that is how you write the answer completely. I'm going to try the next one here. Again, this one is all over the place again. The coefficient is 6 for the highest term, then minus 25. We're missing an x squared term, so we need to add a 0 there, and then a negative 3x and a 5. Now, the factor is x plus 1/3, but the 0 is negative 1/3, so we're going to put negative 1/3 outside. First thing, we're going to bring down the first coefficient, that's 6, and then multiply. 1/3 of 6 is actually 2, and that's negative. So combining, we have negative 27. Multiplying 1/3 of 27 is 9. Negative times negative is positive. And combine it into 9. A third of 9 is 3, and it's negative. So that's negative 6, and that's going to be giving me a 2 positive, and the remainder is 7. So p of x in this case is the divisor, x plus 1/3, times the quotient. Again, I'm going to reduce everything by 1 degree. So we got 6x cubed minus 27x squared plus 9x minus 6. And then finally the remainder is a plus 7. So this is the complete answer for this problem here. Discussion question. Can you use synthetic division to divide a polynomial by x squared plus 3? Explain. No, the answer is no. You may not, because you cannot divide anything with a divisor of higher than a linear, which means 2 or above you cannot use. So you can only use for linear factors, okay? Linear factors. So that's the end of today. Go ahead and go into Google Classroom and look at your assignment and get started. Have a good day.